compare properties of functions. A zebra's main predator is a lion. Lions can run at a speed of 53 feet per second over short distances. Compare the speeds of the zebra and the lion. So we know that 53 feet per second is a rate of change. Remember, rate of change is slope. So for the lion, the slope is equal to 53. Now we can find the rate of change for the zebra. That's the change in distance over the change in time. And we can calculate this by using the slope formula. And choosing any two ordered pairs to find the change in y over the change in x. So I'm going to use the first two ordered pairs. And this is for the zebra. This one was for the lion. So I'm going to pick the two y values, 118, subtract 59, over the change in time, 2 seconds and 1 second. 2 seconds minus 1 second. And when you subtract the numerator, 118 minus 59 is 59, and 2 minus 1 is 1. So the slope is 59 feet per second for the zebra. It says compare the two speeds. So we know that the zebra was 59 and the lion was 53. So the zebra's speed is greater than the lion's. Example number 2. The function m equals 140h, where m is miles traveled in h hours, represents the distance traveled of the first Japanese high-speed train. The distance traveled of a high-speed train operating today in China is shown in the table. So we're given an equation to represent one scenario and a table to represent the other. And part A says identify the y-intercepts and rate of change for both trains. So let's identify the y-intercept for the Japanese train. We have m, that's like our output, and h is our input. 140 would represent our slope, our rate of change. So this would be 140. And the y-intercept, that's our b value. We don't see it. It's plus 0. So the y-intercept is 0. And for China, we have to calculate the y-intercept and rate of change. Well, we can calculate the rate of change. That's the slope formula. Pick any 2 points to find the slope. And I'm going to choose the first two. 434 minus 217. I'm subtracting my y values. And looking at my corresponding x values, 1 and 2, I'm going to subtract those also. 434 subtract 217 is 217. 2 minus 1 is 1. So the rate of change for the China train is 217 miles per hour. 217 miles for every 1 hour. The y-intercept we can calculate also by using y equals mx plus b form. I'm going to choose an output, 217. I know my slope because I just calculated it, and it's equal to 217 as well. I'm choosing an x value that goes with my y value, 1, and I'm calculating the b. 217 times 1 is 217. Subtract 217 from both sides. And you should see that 217 cancels out on both sides, which makes the y-intercept 0. So we have calculated the rate of change for China, 217, with a y-intercept of 0. And for Japan, the rate of change was 140, and the y-intercept was also 0. How far will you travel on each train after 5 hours? So we could complete the table for the China train 4 hours, we see that if the rate of change is 217, for every 1 hour that we add 217 miles. So we can increase this by 217 also. That would give us 4 hours. Increase again by 217 to give us 5 hours. So let's calculate this. $217 plus 651 gives us 868. And add another 217, and we get 1,085. So if you take the train in China, you will go 1,085 miles. If you take the train in Japan, let's find out how many miles you will travel. So we know that for Japan, we are given an equation. Miles is equal to 140 times the number of hours. Well, our number of hours is given to us, that's 5. So our miles will be equal to 140 times 5. And that's a 5. 140 times 5 is 700. So in Japan, we would go 700 miles, whereas in China, we would go 1,085 miles. And this should make sense because the rate of change in Japan was only 140, and the rate of change in China was 217. Obviously, you'll go farther in China in 5 hours than you would in Japan. Example number 3. Sally needs to rent a moving truck. The cost to rent a truck from 2 different companies is shown in the table and the graph. So here's company A, shown by a table, and here's company B, shown by a graph. Which company should she use to rent the truck for 40 miles? So there's a couple different ways that you could approach this. And let's see, if we're increasing each time by 10 miles, we are increasing each time by $25. So let's continue this table. At 40 miles, she would go, or at 40 miles, it would be $100. And that's what we were asked for. So for company A, it would cost $100. For company B, we are given 2 ordered pairs on this graph, and we can find out how many dollars it's going to charge her per mile. And we can also identify the y-intercept, which appears to be at 0 miles, $30. So this company, company B, is going to charge us $30 plus however many dollars per mile. And let's calculate that. So the rate of change, that's 45 minus 35, subtract your y values, divided by, subtract your x values, 30 minus 10. This gives us 10 over 20. And if we change this to a decimal, that's 50 cents. So 50 cents per mile. Okay? Let's write an equation. So $30 plus 50 cents for every mile. Let's call those M. And we need to go 40 miles. So we can replace M with 40 and calculate how much company B is going to charge. So 40 times 50 cents is $20 plus $30 just to use the truck. So company B is going to charge $50, whereas company A is going to charge $100. Which company should she choose? She should choose company B.